Welcome back to LeetCode Daily Live, where I do the LeetCode Daily question raw and uncut. So let's get started. So we have yet another medium today. Let's see. We want the length of the longest Fibonacci sequence. So I'm sure all of you guys know what Fibonacci is. It's basically like the sequence, like to generate the next number, you sum up the last two elements. Yeah. So that'll be that. And then, well, actually, it says Fibonacci like, right, but it has the same definition here. So okay, so given a straightly increasing array of positive integers forming a sequence, we want to return the length of the longest Fibonacci like subsequence of array, and if one doesn't exist, so right, so if none of them exist, we want to return 0. A subsequence is derived from another sequence by deleting any number of elements. So that means it doesn't have to be contiguous. Right, so let's have a look. I feel like today's one might not be that easy, but yeah, let's just have a look first. So yeah, so it also doesn't limit the first two numbers. As long as the third number you can like add it on and something like that'll work. But our length is actually only 1,000. Okay, so we can have some like n squared solution. Also the array is strictly increasing here. Yeah, strictly increasing. Maybe that will also help as well. But let's see. Different things that we can do. So, do we have 1, 2, 3? So to find out the base case, so that would be like, what would that be actually like? Oh yeah, so that would be like to find the base case, we just want to sum up like each of the like maybe not sum up all of the numbers. That might be a bit too slow. But like maybe we can have a map. So basically we store is that where the n squared part actually comes from? Cause like one way we can do like for this number maybe is like we can check whether we can make a sum from like the previous words the previous numbers. So for example for 5, like if we have like some map that stores well all the previous numbers, then we can like just loop through like all the numbers before, and you know like the two sum technique, like you add it into a set and then you do like 5 minus like whatever number you're looking at, and then you see whether like that number is there already. And also we're guaranteed that we won't have like a 2 2 4 kind of situation because of the constraints here. Like the array is going to be strictly increasing. Yeah, what other observation can we make? Yeah, so that would be the base case. I think we definitely have to like do some DP here. So like if we can, like the thing is, we might not actually like care too much about like what comes after, like what comes like a bit too like far before, right? Because like let's say we are looking at I don't know, let's say we are looking at 7, right? So like one way to form for 7 would be like 2 5 7, like 3 4 7. Is that a good example? Let me think of a better one. I am. Let's say we're looking at 8. Yeah, let's rub this out. Let's say we are looking at 8. So when we look at 8, well, what sequences or like pairs forms 8? Well, it will be 3 5, and then you have 2 6, you have 1 7. But other than that, we just want a quick way to get the like we just want to get the longest subsequence that ends with 3 and 5, and only if it ends like with 3 and 5, like it should only use the things before, right? So in that case, yes, actually, like when we look at 5, we did look at 2 3, right? So we have to like somehow store the length, and then we just kind of like build up, I think. Yeah, so like if we are doing DP, we always have to consider the states. So when I say states, I mean like how, like let's say for DPI, like what does DPI mean? In this case, I think we need a 2D array, a 2D DP array, because like we are dealing with pairs of elements. I guess another way we can do is like we can look at each pair. So like just like the normal DP, but then like we want to find the biggest, like the longest subsequence that ends with like the two the two numbers that we have chosen. So like if we choose like index 0 and index 1, so that'll be 1 and 2. Of course, there's like nothing before that, so like the length of that should just be can we set it as 2? I guess we can. And does it say, yeah, if 1 does not exist, we want to return 0, right? So if our final maximum length is 2, we know that like we know that like from the constraints here, it has to be like 3 or longer. So like if the final is 2, you can just return 0. So that shouldn't be a problem. And then we should look at like index 0 and index 2. The reason I'm doing this instead of like doing like the other way you can do is like 0 1 1 2 2 3 3 4, like in terms of the index, of course. Like you can do something like that, right? But then like you couldn't really like cache from before. Yeah. So yeah, let me think about yeah, also every number is unique as well. Like that's something to really like we should bear in mind as well. So when we are looking at 2 3, when we are looking at 2 3, we want to look at like all the cache, or yeah, we want to look at like all the cache that basically like, because like 2 1 is a pair that we have looked at, right? And obviously like we have the sum to be 3 here, so like we should find some ways to connect that, I think. But how we should connect it, I'm not too sure yet, but we can definitely think about that. Yeah, so when we look at 2 3, what should we do? I think I might see something. So another worry I have is like what happens when we are looking at like 2 5 or something, but then like when we are looking at that, and then like when we do 5 minus 2, like we are trying to find where 3 is, but we actually restricted ourselves so that like when we look at the number 2 and 5, we want those to be the last two numbers, right? So if those are the last two numbers, and 3 is obviously equal or bigger than like the smaller number, that means it like we couldn't have a sequence with that length, if that makes sense. And like when like after we look at 2 5, yeah, I guess like we should have a map that basically like, I don't know, like when we have a map, we should have like the sum and then like the value. So like when we look at 2 5, we should add that in. Uh, yeah, I think we are getting somewhere from this, maybe. Yeah, let's go back to the 1 2 case. So like 1 2, so of course the sum would be 3 here, and then oh wait, it should be 2. Just write that out. So like we can store it as tuples. Like we have 1 and 2, and then of course because like every number is unique, we can like we can store the index map. So the index map is going to tell us like where each number is. Yeah, and like the whole thing is like this is possible. Like the index map is possible because every number is unique. Yeah. Are there negative? Okay, so there are no negative numbers. It goes from like 1 to a billion. Let's see. Yeah, so the next thing we look at would be like 1 3. So like we have a sum of that, of 3, and then like so on. Yeah, we'll have 1 7 and then 1 8. And then like we'll start looking like from 2 and then like, you know, onwards. Yeah, so when we look at 2 3, we can see that the number we have to look for would be 1 and 2, right? Because the second last number is 2. Oh, actually we might not even need this sum then. Okay, let me cook. I think we need to restructure our map. There we go. So map. What if we store the pair and then the length? What if we do that? So like for 1 2, the longest we can form, of course, is just 2. 1 3, the longest we can form, again, it would just be 2. And so on. Like we have all the way up to 1 8, length would be 2. But then when we look at 2 3, well, we can find out what the third element is, right? And the third element is 1. Like because we can just do 3 minus 2, like because of the Fibonacci like sequence requirements. Like we know that the previous thing we should look for is, well, it's 1 and 2. So, and we do find it in our map. So like so if the sequence, like if the longest sequence ending with 1 and 2 is of length 2, well, then if you add like another number at the back, well, you just want to increment that by 1, right? And then yeah, and then when we look at 3 5, well, we'll look at 2 3, and like 2 3, like we'll get 4 here, and then 5 8, like we'll get 5 here because like of 3 5. Yeah, wouldn't that just work? Okay, let me think about other cases. So what if we have what if we're looking at 4 6? That means like we want to look at 2 4. Like obviously 2 4 does exist, but then like it would be of length 2, and so that would be length 3. Yeah, I think that would just work. Yes, that definitely works. Okay, I'm like 99% sure that works. But let's code it out first and see whether it works or not. Yeah, again, there should be a really easy, like, it should be really easy to code it out, but it's definitely like a lot harder to reason with this question. But let's get coding. So what do we want at the beginning? We want a map. So that would be pair to length. So that'll be a map. Is there a map or yeah? So it'll be a map, not a set, because like we will have the pair as the key, and then we'll have the length afterwards. So So pair length, that will be the map. And then yeah, we just want to loop through each pair. So for I in range, we should get we'll just do it here honestly. So the length of array for, yeah, let's make sure we don't mess this up. So I would be the like, it will go here first, and then like it will look at all the numbers, and then like we update I, and then we look at, yeah, okay, so it's just a normal loop for j in range, but we want to go I plus 1 all the way to length of array. So like that basically means like when I is 0, we are looking at the pairs like from like 1 all the way to the end. When I is 1, we are looking like 2 to the end. So we also don't have like duplicates. Like we definitely don't want duplicates. That will create bugs. Yeah, so we just want to do I guess we get the second last and last number first. So that will be like array I, array j, and then we want to form the we want to form like the third last and the second last tuple, right? So I guess like third last, like we can do that as well. Like we just do array j minus array I, and that will definitely be positive, like because the array is surely increasing. I probably have said that way too many times, but let's keep going. So we want to check if yeah, we want to check the pair, right? Like the third last and second last pair. So if that's in like pair to length, we can just do pair to length of second last and last. Well, that will be equal to pair to length third last, second last, plus 1, like with reasons that we have said before. Like if we have seen 1 2, when we have 2 3, well, that means like we can form 1 2 3, right? So we are just adding one element at the back, so we can just do plus 1. Otherwise, well, well, we just want to set it as 2. Like it doesn't have any preceding like Fibonacci sequences that works. And then at the end, yeah, what do we return at the end? I think we want to return the maximum, right? Yeah, we definitely want to like loop through like the whole map and find the maximum. Cause like, what happens if we have I don't know, if we have 100 at the back, like we can't just get the maximum at the back, right? Or I guess we can have a running max as well. So, like longest subsequence, we'll set it as, yeah, we'll set it as 0 at first, and then we can just do, yeah, I guess like if all of the cases runs into this, well, that means like we don't actually have any like length 3 or longer, so we don't even bother updating like the longest, like the best that we have seen so far. So yeah, so we just do it here when we actually find a length 3 or more sequence. So that will be, we just copy this. It's a bit wordy, but I think this should work, unless it doesn't. Okay, it does seem like it works, and it's pretty slow. Okay, it works. It took like 3 seconds. Yeah, there are definitely ways to optimize it, like by not using a map. So a map is like a really big overhead. If you use a 2D array, I think it'll be way faster. So like if we look at other people's code, do they do, oh, they're not actually like using, they're not using a DP array at all. they turn every number to be a set. Is it because like the strictly increasing thing actually? Yeah, so they're looking at each pair as well, while a plus b is in nums. Right, they kind of do like a recursive kind of thing, and just find the longest. Right, so yeah, I think like by avoiding using a map, and also like my map, I'm storing like tuple, and we can have like up to 1,000,000 things in the map, so that's why it is so slow, I think. Um, yeah, yeah. So like the way they do it is like they they set the two elements first. So like what we have done is we have set the last two elements, right? Uh, like whoever that person is, they look at like like they look at like two elements and set it as the first, and like they can basically like just like keep looking up, right? So, and yeah, they can keep looking up, and then like so they set like AB to be 2 3 now, and then it finds 5, so it sets AB to be like 3 5 and so on. But let's see if they if they cache anything actually. If length equals to continue. Yeah, okay, that makes sense. That's to avoid the thing. Um, yeah, like the like this algorithm, the time complexity is actually n cubed, but then like they must be able to cut off the things pretty quickly then. Yeah. Yeah, cause like well first of all um they're looking at each pair just as I do, and also like this thing can go well this thing here is also on because like you're potentially looking at every element like in the array. But I guess like in practice like this wouldn't be on like that much. So yeah. Well, yeah, this question is definitely not the easiest to find the solution for. The code is it's more or less quite simple, I think, to write out. Yeah, but thanks for watching, and I'll see you tomorrow. Bye.